Hi everybody. So I'm Ryan. I'm French, and I'm a bit excited and worried at the same time to be facing you, all specialists and professional of the field, where I just started. Me and Serge, co-founder of, with myself, of Feather Tech. The aim of Feather Tech is to bring a technology to efficiently and cost efficiently go through the onshore seismic surveys. And this presentation will go through the detail and how we do this, and hopefully you will be convinced by then on why you should believe in this technology. So how does this work? Yeah, simple enough. So this first slide illustrates the evolution of the market for exploration and production with time, and one can notice the fairly steady increase of the investment since 2003. However, a bit less steady is the way the market share between offshore and onshore is disputed. Thankfully, at the moment, industries are being fairly interested in investing and spending a bit more on onshore exploration. You can see they're talking about this year a growth of investment for onshore close to 20%. The recent interest for onshore exploration is coming from increasing challenges for offshore drilling. Actually, there is not many big field for typical, I would say, depth of onshore. So it brings the industry to go farther and farther and start exploring and producing in deep seas area. Well, you need to understand that when you're working in deep sea area, and the technical challenges and the cost that therefore comes out of your drilling a well are tremendous. You're talking about drilling a well, and this will cost you close to $100 million. When a typical onshore well will cost you not much more than $5 million. So with such a huge discrepancies in the production numbers, it's normal to wonder why does the industry not completely turn to onshore exploration and production? Well, the answer is in this slide. That's why offshore still dominates the market, and the reason is because it's extremely cheap. Exploration for offshore is close to $5,000 per square kilometer. In comparison, onshore seismic oscillate between $30,000 per square kilometer to up to $200,000 per square kilometer. And that's for even the simplest environment to study, desert. Now, you need to take these numbers and time it by, for example, let's say a small scale a field to study, 100 square kilometer. You're then talking about numbers that goes to $3 million to explore in the desert to up to $20 million in mountains. Well, you compare that to offshore exploration, we're talking about $500,000. So it's at least six times less. So you need to imagine the scenario of, as Bob was mentioning, having during your sampling of the seismic during your survey, and you go through undersampling, then well the survey is you can't do anything about it. It's your 3 to 20 million are poured down the sink. If you use copper cables, and well, copper cables, I'm sure you will get that are made with copper, and copper is extremely expensive in the market at the moment. If you do a survey in a developing country, then these copper cables are very likely to be stolen, to be nicked. And when this happens, then a whole chunk of your survey is absent. And basically, once again, you have a survey that is worth nothing. And your company loses an enormous amount of money. So the huge shortfall between onshore and offshore exploration is the reason why the industry is still reluctant to invest into onshore exploration. Of course, as Bob explained, the burden of onshore exploration is the cable technology. And once we start introducing cable-less technology, or as they mention here, light equipment, you have the onshore exploration that tremendously drop. And so this is where a wireless technology or cable-less technology comes in. But as Bob mentioned, there is a bit of a limitation. This slide talks a bit more into detail and gets more into detail about and compares the different technologies available and where are the limitations. Once you want to do seismic exploration, you want to do it offshore because it has all the advantages. It is low cost, live monitoring, and it allows you to go through quick surveys. On the other hand, if you go through cable exploration, then it has all the drawbacks one can think of. It's intense, HSC exposure is high, it's lengthy, and it's tremendously costly, as we just saw. However, there is other advantages that are very likely the reason why cable technology are still around, is that, well, it has been around for a very long time, so people know what to expect from cable-based technologies, and also it allows you to monitor live the seismic survey. When you start getting rid of the telemetric technologies, cable-less technology, well, as Bob mentioned, this has been around for quite a while, but I would say, penetration of the market. If I remember a number I recall hearing just right here, penetration of the market is not even higher than 10% for cable-less technology. And the reason behind this very disappointing number is signal propagation. When the sensors are on the ground and they can't talk to each other because there is an obstacle, a tree, a river, or even the atmosphere is damp, it's due in the morning, then your system is dependent on the environment, and this is extremely handicapping. So, at the moment, exploration industry is at a cross junction. On one hand, it has the offshore, which is very cheap to explore, but the offshore is very cheap to explore, but extremely expensive to drill and produce. And on the other hand, with a double front of cable-based technology, which is extremely expensive, and cable-less technology, which is not very reliable and a bit disappointing, and a very cheap way of drilling. So there is something to be done to really improve the situation, especially talking about the onshore exploration. And that's where FeatherTech comes in. What the FeatherTech ensures live monitoring of quality control data, so there is no need to shoot blind, and we understood from Bob's presentation that it's only an advantage. And it does this at low cost and with no dependence on the environment, meaning that it does not matter if you gather the signal or transmit your data in the morning. It does not matter if there is a tree separating two sensors. You will still ensure the data transmission. I'm talking about other detail, like, for example, the duration of the survey. I put it similar to the other technologies available, but we have the good hope that with time and experience, we'll do better. And the HAC exposure is much lower than cable technology because you don't have the weight and intensity behind it. So that's the flow chart behind FeatherTech. And what FeatherTech brings to the onshore exploration industry is an advanced, optimized coupling of planning, deployment, data harvesting, and ground unit collection. That's where the riches of FeatherTech is. And every step is actually very important If we want to go, for example, through the planning, that help us deploy units on the ground and brings us a vital understanding on the field. Let's go actually in the next slide in a case study of a multispectral analysis of a field, and actually you will understand a bit better what I'm talking about. This terrain here is a 225 square kilometer desert. A seismic study is in the middle of it's in the Middle East, and a seismic study of the area was required, but there was no reliable data to help with the deployment of the vibro trucks. As we heard from this morning, Middle East is a bit tedious in terms of data availability. Well, the fact that the vibro trucks are 22 tons heavy, and that this region was known to contain quicksand and sabkha, then let your imagination play a little here. And actually, no, you don't have to do that. Just look at this picture here. That's what can happen. And when your vibro trucks is in this situation, it's lost. And to take it out of here is catastrophic. So to avoid, to allow a safer way to deploy the vibro trucks and to go through the seismic survey, we went through a multispectral analysis, and this is luckily enough because the sabkha has a very specific mineralogic signature, and it allowed, thanks to multispectral remote sensing and technology, it allowed us to differentiate between the sabkhas and the surrounding sand dune. And this is the post-treatment analysis resulting from our algorithm and available satellite images. And you can see that from this, you have a much more reliable and systematic mapping of the on-ground sabkha, and therefore you lower tremendously the risk of going through these catastrophic scenarios, and you don't even have to bring man force on the field. So obviously, this is one example. You can combine this with many other sensors, like one of the numerous we heard earlier today, and terrain elevation, etc., to bring the most out of planning. Another part that is very important in FeatherTech flowchart is the data harvesting. It's important, or it's maybe the most important part. It's in this step that we unlock the limitations that the current technology are facing. It's in this step that we ensure a good signal propagation and live monitoring of the deployed sensors. That's a cartoon that shows a very simple, actually lovely scene. In a vineyard, sensors are on the ground, and seismic excitation has happened, and they all happily monitored the bouncing back of the different waves, and they have registered their data. They are all now happy to emit, all in green, their status, except one in red. After that, UAV, unmanned aerial vehicle, approaches the sensors to harvest their status data, QC data. When the smart sensors on the ground lock the position of the UAV once it's at reach, they send their status to the drone. Sensors on the ground have, in this manner, their status near live monitored, and this brings endless benefit. You have no blind shooting, efficient communication protocol, immediate intervention of on-field operator in case of a problem, for example, this red sensor on the ground, fully sampled, high-quality seismic data generated. So I'm now helping myself and backing me up with some slide I found on the internet and in the literature. And this is something that has been published by Ion Geophysical. I don't know these people, but they must be very smart. Because what they say is basically that cable-based, if you take it with, with an index of 100, if you switch to cable-less technology, but a cable-less technology that is reliable, that has no signal propagation issue, and that you can trust, then you can reduce the cost tremendously compared to cable-based technology. And I actually let you, I will read this sentence for you. If we can eliminate cables for onshore acquisition, our industry stands poised to unlock the holy grail of land seismic imaging. Cost-effective, fully sample, full-wave survey. And that's exactly what FeatherTech does. Cost-effective, fully sample, and high-definition seismic survey. So kudos to them. This here is not something I made neither. This is an advertisement provided by one of the leaders of the exploration industry. And what you can see here is a helicopter harvesting the data from sensors on the ground. So all of you might react differently to this. I reacted certainly in a certain way, but I didn't want to be biased. So I asked some of my friends what do they think about it. One of my friends has nothing to do with oil and gas exploration, and he told me, oh, a helicopter, that must be expensive. And another friend of mine, she is a safety officer, and I showed her the picture, and she was like, a helicopter, that must be dangerous. Well, I went to one of my last friends, very bright guy, an engineer, and he told me, a helicopter, there must be a better way to do it. Well, ladies and gentlemen, yes, there is a better way, and it's called FeatherTech. So, if you have any question.
Okay, thanks, Bob, and thanks, Rayane. Anybody got any questions? Yeah, Sean.
So how do you ensure the security of the sensors on the ground?
You mean if someone wants to nick it, or? To
nick it, or if it becomes unserviceable, if it breaks, or if it gets moved. Is there a way of monitoring that?
Yeah, well, a way to answer your question would be that these sensors are fully equipped with geophones. And what the purpose of geophones is to actually monitor the seismic perturbation. And it's extremely sensitive. What I'm talking about is sensitivity so high that it can actually monitor the change in wind, or it can actually monitor if it's raining. So if someone comes in and walk by wanting to pick up the sensor, it will feel for the sensor like an elephant is around. And so basically, with the system we just seen, UAV flying by, catch up the alarm signal, and basically someone can straight ahead impact and react on this. So does it answer your question?
Yeah. So therefore, do you need 24-hour aerial coverage?
No. If you make it, let's say, frequent enough, then it doesn't need to be continuous. It can be with a set interval, and therefore you can have 2 UAVs going through the same sensors on the ground, and basically not having your whole fleet being in the air at all time.
Thanks.
Yeah. Adam?
Yes.
How close do the AUVs have to be to the geophones stations on the ground?
Yeah, that's a really good question. My answer to that will be it depends on the environment. If you are in a desert and it's dry and you're in the middle of the day, then it can be as high as 100 meter, 200 meter, and it will still transmit and receive perfectly fine, because we're talking about low bandwidth data here.
And if you're in an urban environment?
If you're in an urban environment, then you have advanced programming that will make the UAV lock the position, the optimal position for data transmission, and we're talking about something that is close to dozens of meters of altitude to maybe higher. This is something that's...
And so in the UK you couldn't use it because you can't be closer than 400 meters?
Well, That's the UK. There's other place in the world.
Hi, thank you. Geophones, I mean, I agree, they're very, very sensitive indeed. In fact, when I used to be a field engineer, I used to pick up aircraft flying at maybe 20,000 feet.
Right.
Propeller aircraft.
Yeah.
So how about these drones at a few hundred meters?
Well, the aircraft and other noises around are not predictable. However, if you manage to have a characteristic way of calibrating the presence of a UAV around, and then maybe you can back calculate from removing this already known noise and impacts on the seismic signature, and then therefore have a signal that is trustworthy enough.
Hi, Rob Jones from Cairn. What's your wind speed limitation for flying these things over the seismic spread?
Well, I don't have quite an answer to that, but I would say at the moment we, as other speakers have been explaining, we're quite limited by I would say factors, weather factors, and winds, high wind, and because we're working with quite light systems, high wind would be at the moment causing us a bit of trouble. Hopefully, this is just I would say the first step towards a fully developed technology and modular technology also. But at the moment, let's say light wind hopefully would be okay. But if you go in the middle of Scotland, then you're exposing yourself to some issues.
Yeah, Sean, what I was going to say, you must have an answer to that question.
Yeah, with regards to winds and small vehicles, the latest agriculture vehicle I've got, you can fly in 40 knots of wind with no problem whatsoever with regards to the sensors, and that's pretty windy. So, and as the technology is increasing, that's only going to go up as well.
No. Okay, thanks, Ryan. Thanks, Bob.
Thank you very much.
Thank you very much.